Deep within the Earth, a silent revolution is brewing. A clean energy source, hidden for millennia, is finally coming into focus. This hidden treasure is geologic hydrogen, a naturally occurring form of hydrogen gas trapped within the Earth's crust. For decades, we've searched for sustainable alternatives to fossil fuels. We've looked to the skies for solar power and harnessed the wind's energy. Now, we're turning our attention downwards to the very ground beneath our feet. Geologic hydrogen holds the promise of a clean energy future, a future where we can power our world without polluting our planet. This is not science fiction. It is a burgeoning field of scientific exploration with the potential to reshape our energy landscape. Join us as we delve into the world of geologic hydrogen, exploring its origins, its potential, and the challenges we face in unlocking its power. Geologic hydrogen doesn't appear overnight. It is the product of natural processes occurring over vast stretches of time within the Earth's crust. These processes, often occurring at high temperatures and pressures, transform common elements and compounds into pure hydrogen gas. Let's take a closer look at these remarkable natural hydrogen factories. A. Serpentinization. Deep within the Earth's mantle, a fascinating dance between rock and water takes place. When water interacts with certain types of rocks like peridotite, a chemical reaction occurs. This reaction, known as serpentinization, generates hydrogen as a byproduct. B. Radiolysis of water. The Earth's crust contains naturally occurring radioactive elements like uranium and thorium. These elements emit radiation, which can split water molecules into hydrogen and oxygen. This process, known as radiolysis, contributes to the accumulation of geologic hydrogen. C. Iron oxidation. Iron, a common element in the Earth's crust, plays a crucial role in hydrogen formation. When iron reacts with water, it oxidizes or rusts. This process releases hydrogen as a byproduct. D. Mantle degassing. The Earth's mantle, the layer beneath the crust, contains vast stores of hydrogen. Volcanic activity and tectonic plate movement can create pathways for this hydrogen to escape to the surface, contributing to geologic hydrogen reserves. E. Biogenic and microbial processes. It's not just geological forces at play, even tiny organisms contribute to hydrogen production. Certain types of bacteria living deep underground consume organic matter and release hydrogen as a waste product. Imagine walking through a field and seeing bubbles rising from the ground. Now imagine these bubbles are filled not with air, but with hydrogen gas. This is the reality in certain parts of the world where natural hydrogen seeps offer tantalizing clues to the vast reserves hidden beneath our feet. These seeps, often found in areas with geological activity like fault lines and rift valleys, provide direct evidence of subsurface hydrogen accumulation. Scientists have documented natural hydrogen seeps in locations as diverse as the United States, Canada, Brazil, Russia, and Australia. One notable example is the St. Lawrence Lowlands region of Canada, where numerous hydrogen seeps have been discovered. Analysis of these seeps suggests that the hydrogen originates from deep underground, likely produced through serpentinization. These findings highlight the potential for commercially viable geologic hydrogen resources in various locations around the globe. The hunt for hydrogen's hidden reserves is on, and these natural seeps serve as valuable signposts, guiding us towards potentially significant deposits. Discovering geologic hydrogen is only the first step. To harness its potential, we need to develop effective methods for exploration and extraction. Fortunately, many of the techniques used in the oil and gas industry can be adapted for geologic hydrogen. Geophysical surveys, for example, can help identify underground structures that may trap hydrogen. These surveys use sound waves or magnetic fields to create images of the subsurface, revealing potential hydrogen reservoirs. Once a potential reservoir is identified, exploratory drilling can be used to confirm the presence of hydrogen and assess its volume and flow rate. This involves drilling a well into the target formation and collecting samples for analysis. Extracting geologic hydrogen is relatively straightforward. Once a well is drilled, the natural pressure of the reservoir can often force the hydrogen gas to the surface. In some cases, pumps may be needed to assist with extraction. While the technology for exploring and extracting geologic hydrogen is still under development, the similarities to existing oil and gas practices provide a solid foundation for rapid progress in this field. What makes geologic hydrogen so compelling as an energy source? There are several key advantages that set it apart from other forms of hydrogen and position it as a potential game-changer in the clean energy landscape. Firstly, geologic hydrogen is naturally occurring and abundant. Unlike hydrogen produced from fossil fuels or electrolysis, which require significant energy inputs, geologic hydrogen is readily available within the Earth's crust. Secondly, geologic hydrogen is a truly clean energy source. When burned, it produces only water vapor, emitting no greenhouse gases or other pollutants. This makes it a far more environmentally friendly option compared to fossil fuels. Thirdly, geologic hydrogen can be stored underground in its natural reservoirs. This eliminates the need for large, expensive storage facilities, which are often required for other forms of renewable energy like solar and wind power. These advantages, combined with the ongoing advancements in exploration and extraction technologies, make geologic hydrogen a highly promising alternative energy source with the potential to revolutionize the way we power our world. While the potential of geologic hydrogen is vast, there are still challenges and uncertainties that need to be addressed before it can become a mainstream energy source. One key challenge is the need for further exploration to accurately assess the size and distribution of geologic hydrogen resources worldwide. While initial findings are promising, more data is needed to determine the true extent of this hidden energy source. Another challenge is the development of efficient and cost-effective extraction technologies. While existing oil and gas technologies provide a starting point, further innovation is needed to optimize hydrogen extraction from deep underground reservoirs. Moreover, the environmental impact of geologic hydrogen extraction needs to be carefully assessed and minimized. While hydrogen itself is a clean energy source, the extraction process could potentially have environmental consequences, such as groundwater contamination or induced seismicity, that need to be carefully managed. Addressing these challenges will require continued research, technological innovation, and collaboration between scientists, engineers, and policymakers. The search for and development of geologic hydrogen is not confined to a single nation. Around the world, researchers, companies, and governments are recognizing the immense potential of this resource and are investing in exploration and development efforts. In the United States, the Department of Energy has launched initiatives to support research and development of geologic hydrogen technologies. Startup companies are also emerging, focusing on developing innovative exploration and extraction methods. Europe is also at the forefront of geologic hydrogen research, with projects underway in countries like France and Germany. Australia is actively exploring their own potential geologic hydrogen resources. This global effort highlights the growing recognition of geologic hydrogen as a key player in the future of clean energy. As research progresses and technology advances, we can expect to see a rapid increase in the pace of geologic hydrogen development worldwide. Imagine a future where clean, abundant energy flows from the Earth itself. A future where we power our homes, our industries, and our transportation systems with hydrogen produced naturally within our planet. This is the promise of geologic hydrogen. While the journey towards a hydrogen-powered future is still in its early stages, the potential benefits are undeniable. Geologic hydrogen offers a pathway to a more sustainable and equitable energy future, reducing our reliance on fossil fuels and mitigating the effects of climate change. The road ahead will require continued innovation, collaboration, and a commitment to unlocking the secrets of this hidden energy gem. But the potential rewards, a cleaner planet and a brighter future for generations to come, make this a journey worth taking. As we venture into the uncharted territory of geologic hydrogen, we are embarking on a journey that could redefine our relationship with energy and pave the way for a truly sustainable future. The Earth once again holds the key to our energy needs, this time in the form of a hidden gem waiting to be unearthed.